All right, let's start talking our way through this bell work today. Number one should look pretty familiar. When I look at this one, first thing I simplify is anything that comes after the plus or minus. I circle all of that, and I grab it all and move it off to the side. So 2 square root of 12. And just as a reminder, that 2 is being multiplied to the square root of 12. That's going to be really important with anything else that we decide to pull out, because it would get multiplied to that 2 that's already out front. 6 and 2. Are both of those prime? No. 6 can be broken down to 3 and 2. So what would I have when it's all broken down underneath the radical?
6 and...
Not 6. I want only prime numbers. I want it totally broken down. I'm kind of skipping some steps here. Yes. And I apologize if I wasn't clear in the way I was asking my question. 2 times 2 times 3. I'm just trying to save myself a little bit of room because I don't have a lot of space to write up here. Can anything come out? Yes. I've got a pair of 2's right here. I already have a 2 that's out front. So that 2 that's out front stays there. But now I'm going to multiply that to the 2 that I take out. And that in turn gets multiplied to my square root of 3. So out front I have this 2 times 2. What is 2 times 2? So I have 4 square root of 3. That's what's going to take the place of 2 square root of 12. So I have 4 plus or minus 4 square root of 3 all over 8. Now I'm looking at any numbers that are not underneath a radical. So this 4 here, and this 8 right down here. I can divide them all by 4. Remember, I always want to go after the biggest thing that'll go into all of them. One, yes, and I do need to write that down. So I have 1 plus or minus radical 3 all over 2. That would be my fully simplified answer right there. Number 2. Number 2 was review of some Algebra 1 stuff. We haven't really talked a lot about properties of exponents problems. We will as we move forward, but this was just kind of see what you guys remembered. Very first thing about number 2 that jumps out at me is this negative exponent right here on b. This is the first thing I need to take care of. Does anybody remember from what you've studied before what you do when you have something that has a negative power on it? Close. Very close. We're going to move it to the opposite side of the fraction first, yes. So since this one is up on top, I'm going to move it to the bottom. But if I saw something that had negative powers and it was in the bottom, then I would move it up to the top. What happens to it now that I moved it? Becomes a positive. So I still have my a squared in my numerator. I have a squared and b in the denominator, but now I also have a b to the 3rd power in my denominator. And similar to the previous problem where the 2 and the square root of 12 were being multiplied, all these pieces down in the denominator are being multiplied together. I have b and b down here.
Do you have to move a?
We will, yes. I'll take care of that one in a minute. Since we just moved the b, I'm going to focus on that for a minute, but there's nothing wrong if you started with the a's. I want to combine these two b's together, so I only have one b.
So that does the b have an imaginary, like, exponent?
Yes, it has a little invisible 1 right here. What do I do with those powers now? We add the powers. The bases are being multiplied. Here's what's going on. Here's why I'm going to add them. So up here I have a squared and a squared. And then I have this b, which we said was to the 1st power, right? What does b to the 3rd mean? B multiplied by itself 3 times. So I can write out this idea of b cubed like this. How many b's do I have that are all being multiplied together? 4. So this is b to the 4th power. That's why I'm adding those powers there. Okay, so in my numerator, I have a squared In my denominator, I have a squared and I have b to the fourth. And now we're going to shift gears and we're going to look at these a's. A squared divided by a squared. What would happen there? Cancels out. Another way to think about it is when they're on opposite sides of the fraction, I'm going to subtract their powers. This is exactly the same as what you were talking about with canceling, but I can use this idea even when the powers aren't exactly the same. What is 2 minus 2? So this would be a to the 0 power. That's what I would have up in my numerator. I wouldn't have a to any power in my denominator. This combines them together. And there's one last thing we need to do. Anything at all, if it has an exponent of 0 on it, becomes a 1. That's correct. So my final fully simplified answer would be 1 over b to the fourth power. All right, last one on the bell work for today, number 3. It says select all the factors. So I want the things that will multiply together to give me 4x squared minus 49. When I see this x squared, and I know we're looking at a quadratic equation. Quadratic equations have a, b, and c, right? But I only have 2 pieces here. Is that 4x squared a or b or c?
A.
That's a. What about this negative 49? Is that b or c? That's c. What's in between these? Sorry, what symbol is in between the 4x squared and the 49? Right here. What is that? Minus. This is a difference of 2 perfect squares. When I have a difference of 2 perfect squares, the way I factor that, the way I figure out what multiplies to give me that, is that I will take my first term and I will square root it. So 2, and what's the square root of x squared? 2x. So my factor I know has to have a 2x in it. That means that I can eliminate this one, because that doesn't have a 2x. This one has a 4x. Nope. This one over here just has an x squared. Yeah, so I can throw those 3 out because they don't have a 2x in them. Then I have to take the square root of my c term. What's the square root of 49? 7. Well, this one has a 2x and a 7. This one has a 2x and a 7. So is my answer B, or is my answer D, or is my answer both of them? Both of them. Absolutely correct. So B is a factor and D is a factor. When we factor a difference of 2 perfect squares, they'll have the same first term, they'll have the same second term, but then they will have different signs in between them. One will have a plus and one will have a minus. Do you guys have any questions for me on the bell work? All right. Flip in your books for me then to page 49. Page 49. We've been talking about factoring things. We've been talking about quadratic formula. We're going to keep going with studying quadratics, but we're just going to build on the knowledge that we've acquired so far. A quadratic function has the general form, and you guys have written this down with me before already. We usually have either function notation or a y equals, and then my general form is that ax squared plus bx plus c. When I look at a quadratic function and it's been graphed on my page, what letter does it look like? It looks like a U. Does anybody remember what that U-shaped graph is called? A parabola, that's correct. So the function is called a quadratic function, but the shape of the graph is called a parabola. This parabola over here that's been graphed, this is the parent function, y equals x squared. Any kind of functions that we talk about, the parent is the most basic of that form. It's the simplest one to graph. It's the easiest one to wrap our minds around. Not today, but tomorrow, we'll talk about how if we know enough about what the parent function looks like, I can look at any kind of complicated equation that is of this same form, and I can know what's going to be the same and what's going to be different from the parent function. The highest or lowest point is called the vertex. So this point right here, that is the vertex on this graph. What is that ordered pair there? Close. It's right where those two dark lines are crossing.
Oh, you're
0,
zero.
0, it's at the origin. Yep. Yep, there's my vertex. If it is the highest point on the graph, sometimes we might also call it the maximum. So that gets used interchangeably with vertex. If it's the lowest point, what do you think we could also call it? The minimum, yes. And then last thing that we need to talk about right here, the roots, solutions, or zeros. Can you guys think of another synonym for roots, solutions, and zeros? This is the same as the x-intercepts on a graph. Or where the parabola crosses the x-axis. So if I'm looking at this parent function right here, the parent function only touches the x-axis right there at the vertex. But many of our other parabolas have two places that it will cross the x-axis at. All right. There are three different forms that a quadratic function can take. Do you guys remember with lines, there's y equals mx plus b form?
Yes.
That's our slope-intercept form. And then lines also have general form, the ax plus by equals c. And they tell you different pieces of information, but they're both just lines. Quadratic functions have the same kind of thing. We've already talked about two of those forms. We've got general form. We wrote that down up above. F of x equals ax squared plus bx plus c. This form is super useful because when my equation is written in this form right here, I don't have to do any math to it at all. I can just look at it the way it's written, and I can identify the y-intercept. The y-intercept, when it's written in this form, y-intercepts always start with a 0. And then where it crosses the x-axis, that will always be my c value. With slope-intercept form, that's your b value, right? Y equals mx plus b. In this case, it's your c value. It's the one that doesn't have any variables with it.
Oh, kind of like a quadratic formula.
Mm-hmm.
It doesn't have any values with it. I mean, any variables with it.
Yep, that's right. Then we have factored form, and we've talked about factored form in here as well. When I see an equation written in factored form, if there is a GCF, that's always at the beginning, and we're going to call that our A value. That's the same A as the general form, by the way. Same number. And then we've got sets of parentheses. We have x minus r1, x minus r2. I'm using the r's there to mean roots, because that's a synonym for x-intercepts. And I have them labeled 1 and 2 because it's usually two different places, two different numbers. So root 1 and root 2. Factored form is a really useful form for us because we can very easily identify the x-intercepts from this. Remember, our roots are our x-intercepts. The way I find my x-intercepts, I'm going to take those factors and set them equal to 0. And then we will solve for each of those roots. So if it's subtraction, that means I add it to both sides. And if it's addition, then I would have to subtract it from both sides. And so I get x equals r1. That's what I would use to write one of my ordered pairs for my x-intercepts. X-intercepts always start with where it crosses the x-axis, and then it's always followed by a 0. To find my other root, my other x-intercept, I would do the exact same thing. So same process to get my other x-intercept, because we're almost always going to have 2 there. So again, it always starts with where it crosses the x-axis, and then it'll have a 0 for where the y goes. Are we good with those 2 so far?
Yes.
All right. The last form, and this is the new one that we're adding on today. This is called vertex form. General form tells me where the y-intercept is. Factored form tells me where the x-intercepts are. Does anybody want to take a guess what feature of a quadratic graph I can easily identify from vertex form? Close. I can tell that, but I can tell that from all 3 of the forms. But you're right, that is one of the things that I can find in this form. From this form, this is the only one that tells me from its form name what I can find. I can find my vertex. The vertex is always going to be HK. This one can get just a little bit tricky because of H there. Or sorry, yeah, H. K, whatever number I see, that's what I pop in right here. So if it's a +2, I have a +2. If it's a -7, then it's -7. Do you guys see how the H is inside parentheses? What did we do with factored form since those were also inside parentheses? What did I have to do to find my actual roots?
Oh,
What did I do right here?
You gotta subtract.
Yeah, I had to set it equal to 0, and then I had to subtract and solve. Same exact thing here. To find that H value, I take whatever is inside those parentheses and I set it equal to 0, and then I use that to solve for H. When you're looking at this here, notice inside these parentheses, when I wrote it down up here, it had a minus. But when I found the root, it was a positive because I had to add it to both sides, right? If this had had a plus here, I would have had to subtract it from both sides. So my roots are always going to have the opposite sign of whatever I see here. Same thing is true about H. So as you guys get more and more used to this, you're always welcome to actually set it equal to 0. But if you can start looking at it and saying, oh, I see a -3. If I set it equal to 0, I have to add 3 to both sides. So what I'm actually going to put here is a positive 3. That's okay. I don't have to see your work on finding h. I want to practice with a couple of these now. Look down at the bottom of the page. We're going to start off by just identifying what form is that equation written in. And then we're going to figure out what is the feature that I can identify. And we're going to name it. So on A, this is the first one I'm looking at. Vertex form, yes. What can I identify from vertex form? Maximum or minimum, my vertex, yes. So I actually want to name that ordered pair. I know the second number is going to be a 2 because I see that right here. How do I find the first number? The first part of my ordered pair. Yep, I'm going to do x minus 4, and I'm going to set it equal to 0. So then I would need to add 4 to both sides. So where is the x part of this ordered pair then? X equals 4. So I'm going to grab the number and pop it in right here.
No, don't worry about squaring it.
Nope.
It's just our points.
Yep, it's our points. You're right, we don't have to square it. The parentheses are squared, but to find my vertex, I just want that piece on the inside. What form is B written in?
General term.
General form. What can I identify from general form?
Or y-intercept.
Y-intercept. Y-intercept always starts with what number? 0. It's always starting with a 0. Where does this particular parabola cross the y-axis at? At 6. It's a positive 6 here, so that's what I bring down. 0, 6 would be my y-intercept. What form has C been written in? That is factored form.
Let's define your x-intercept.
That's how we find our x-intercepts. That's correct. How many x-intercepts am I going to get from this? 2. I know that the second number in an x-intercept is always a 0, but I don't know what the first number is. How do I find the first number?
1 plus 4 minus
Yep, so I do x plus 4 equals 0. So I'd subtract 4 from both sides. One of those x-intercepts is at negative 4.
And then the other one's positive.
The other one is positive 2. That's correct. Because I would take x minus 2, set it equal to 0. Here I have to add 2 to both sides. So I get that x is positive 2. This is the part that I was saying, if you guys can look at those factors and know what you're going to do so that you can just write down the minus 4 or the positive 2, I don't have to see where you've set it equal to 0 on your work necessarily. I want you guys to practice with D, E, and F. I'm going to give you about 3 minutes for those 3 problems, and then we'll check in. All right, let's talk about these. What form is D in? Factored form. So I know from factored form I can find my x-intercepts. Where are these x-intercepts? Give me the whole ordered pair.
x plus 5.
So it's going to be 2 and then 0. So we have a positive 2 from the first one. Negative 5, 0. There's going to be a lot of places in this unit where I want you to tell me those roots or solutions as ordered pairs like this right here. Yes. What form has E been written in?
General.
General form. And what can we tell from that? C is our y-intercept. So where would the y-intercept be?
Negative 16.
Give me the whole ordered pair.
0, negative 16.
Wonderful. 0, negative 16 is my ordered pair. And then what about the last one? What form is he in?
Vertex.
Vertex form. So where would my vertex be?
Minus 3. X minus, would be minus 3, so it would be negative 3. Minus 8.
Yes, -3 and -8. Remember, this one comes straight down. We don't have to set it equal to 0 because it's not inside parentheses. Anytime it's inside parentheses, you've got to set it equal to 0. And if it's not inside parentheses, like C or K, we just grab that number. You guys okay with these?
Yeah.
All right, I'm going to skip G and H right now for time because we have to go over to page 50. We have to talk about one more important concept. We're going to talk about the axis of symmetry. What does it mean if something is symmetrical?
It's perfectly even on both sides.
Perfectly even on both sides, yes. So the axis of symmetry, yep, this is the line that evenly divides my parabola in half. The line that evenly divides the parabola in half. I'm going to try to fit that all on one line here. So one of the ways I think about this, probably because my daughter's in kindergarten right now, the axis of symmetry is kind of like those dashed lines that you had to cut along when you were learning how to cut. Do you guys remember doing that?
Yes.
Cut along the dotted lines. So when I'm thinking about a parabola, like this, if this is my parabola here, the axis of symmetry has to cut it exactly in half. So like this. And I need to know the whole dotted line, which means we need an equation here. It's always going to go through either the maximum or minimum, the vertex. So if I know where the vertex is, I know where that line goes. When they give me the equation in vertex form, super easy. This is x equals h, which we've been doing to find the h part of that ordered pair. Only now for my axis of symmetry, I have to include the x equals part, because just putting a number there is just a dot, a point, and I need that whole dotted line there. When they give it to me in factored form, we're going to have to do a little bit of work with this. I need to know where my two roots are, and I add them together, and then I divide it in half. This gives me the halfway point between those two x-intercepts, and the vertex is always halfway between my x-intercepts. And then the last one, my general form. Ooh, I forgot my x equals. Sorry, that's actually super important. Please include the x equals on there. I can't believe I forgot to write it. Hugely important, because again, just a number is a dot. I need the x equals to make that whole dotted line. General form, x equals, and we're going to have to do a little bit of work for this one too. In my numerator, I'm going to have the opposite of whatever my b value is. Does that look familiar at all? Having a fraction and starting the top with negative b. It's a lot like quadratic formula, right? That's exactly where this comes from. Down in the denominator, 2 times a. So I find the vertex, or I find that axis of symmetry the same way I use quadratic formula, but I don't have to worry about the radical at all, and I don't have to do the discriminant. All right, I want to look at some of these examples down at the bottom, and we're going to practice. I need to know what form I'm in, so I know which one of these to use. What form has number 1 been written in?
Vertex.
Vertex form. How did you know?
Because you only have one set of parentheses.
only have one set of parentheses. And what's true about those parentheses?
They have a square.
Yes, those parentheses are squared. Those are some key visual things you can be looking for. How do I find the axis of symmetry in this form? Yes, x equals h. So I'm going to take these parentheses, that x plus 4, I'm going to set it equal to 0. Yep, subtract 4 from both sides. I get x equals negative 4. I have to grab this whole thing and put it on the line, not just the negative 4, but the x equals also. Without the x equals, it is wrong. Because without the x equals, you haven't given me that dotted line for my kindergartner to cut along. What form has number 2 been written in?
General.
Which form?
General.
This one is general form. General form will never have parentheses in it, anywhere. The other 2 forms always have parentheses. This form does not. To find the vertex from general form, I'm going to use just a piece of the quadratic formula. I'm going to do negative b divided by 2 times a. What is my b value? 3. So I'm going to take this right here. Here's my b. That goes in here.
And your A value is 1.
A value is 1. My leading coefficient is a 1, and so that's what I put in right here. So, well, remember, I'm multiplying. I have negative and a 3. So what's in my numerator then? Negative 3.
Negative 3 over 2.
Negative 3 over 2, because I do 2 times 1, so that's 2. So this is what x is equal to. So x equals
Negative 3 over 2.
-3 over 2. Yep. I want you guys to do number 3 on your own. Practice with number 3 on your own. What form is number 3 in? General form. So I need to do negative b divided by 2 times a. What are we putting in for b? Negative 2. That's correct. The negative and the negative right here will become a positive 2 over 10, because we're going to grab this 5. Yes, we can.
So 1/5.
1/5, because I can take a 2 out of both of those, and I get 1/5. So x equals 1 over 5.
Is it okay if you put like x equals 2 times 1 over 5?
X equals what? 2/10 or 1 over 5? I wouldn't count that as wrong, but on tests and homework and stuff, it wants it in fully reduced form. Good question. What form is number 4 in? Factored form. For factored form, I need to know where my roots are, because I'm going to take those and add them together and divide by 2. Where is one of our x-intercepts here?
Positive 2.
Positive 2. Where's the other one at?
Negative 3.
-3, and then I'm going to divide that by 2. 2 plus -3, that's the same as 2 minus 3. What is 2 minus 3?
Negative 1.
-1 over 2. So where is my axis of symmetry?
So 0.5.
Yep. Tell me what the whole equation is, though, because remember, I need an equation.
X equals 1 over 2.
Yep. X equals -1 over 2 Or you could write x equals negative 0.5. Awesome. Your first homework assignment of this unit isn't due until Monday. You guys are welcome to get started on it if you would like, but it uses some information that we're not learning until tomorrow. Unit 2 test is set right now for Friday, September 17th. Your Unit 1 test will be in Skyward before the end of the weekend. All right? I hope you guys have a fantastic rest of your day. Please let me know if you need anything at all.